my name is Engr1315 and this is my pulley project for Engr1315. Pulleys have been used for a long time. They are a simple machine that helps make lifting heavy objects a lot easier. So they cut down the force needed to lift them, so it makes lifting them a lot easier. Here in my diagram of my pulley, I have it shown that when I pull down with a force on this rope, the mass that I have hanging from the pulleys is the weight of that is equal to the tension displayed in the 4 ropes that are attached to it, and they are divided up equally to equal the same amount as the force due to gravity on the weight. So when I pull down with a force on this rope, it is equal to the amount of force for the tension on one of these ropes, and all of those add up to cancel out the mass of the weight being lifted. So when I pull down with this rope, it will lift up the pulley, and it makes lifting it a lot easier than if I were to lift it directly straight up with just picking it up. So I have created a MATLAB program to calculate the force needed to lift it. Let me talk you through my program real quick. I started off with a menu operator, which if we hit run, will ask the user which weight are you lifting, and you can select which one, 5, 10, 15, or 20 pounds. So we are using the 5 pounds right now. So then it asks, what is the mechanical advantage of your pulley system? My mechanical advantage for this pulley system is 4, because I have 4 pulleys. So we're going to enter 4. And it tells me the force needed to lift 5 pounds with 4 pulleys is about 5 newtons. So just for comparison, we're going to see what it would be like if I didn't have a pulley. So we're going to enter a mechanical advantage of 1, be about 22 newtons. So that's about 4 times as much. And in my program, I have a logical loop. So if I select the first menu option, then I have a weight of 5. If I select the second, then it's a weight of 10, and so on. I have also included in there the conversion between pounds to kilograms. So over here in my workspace, you can see that the weight of the mass in kilograms is 2, and then in pounds it's 5. And then I also have the force, where it calculates the force. It would be force is mass times acceleration, so we have the weight in kilograms times 9.8, the force due to gravity, divided by the mechanical advantage of the system. And then I display it all back out in a string. So with 4 pulleys, that makes the force to lift it 4 times as less. So we're going to switch out this weight. This was 5 pounds. We're going to try it with 10 now. It's a little heavier to pick up, but hopefully the pulleys will make it easier to lift. So here we're lifting 10 pounds, and the pulleys make it a lot easier. But there is a trade-off with pulleys, because although you are doing a lot less force to lift it, you are having to pull the rope a much longer distance. So when I pull this up, I have all this rope here, lots of it, because when I have 4 pulleys, although the force is quartered, the distance that I'm having to pull the rope is quadrupled. So if I were to only have 1 pulley right here connected directly to the mass, then if I pulled the rope 1 meter, the mass would raise 1 meter. But here I would have to pull 4 meters of rope to lift the mass 1 meter. So let's go back to the program and see how much force we did for that one. So that was 10 pounds. So we're going to enter that. 4 for the mechanical advantage. The force needed to lift 10 pounds with 4 pulleys is about 11 newtons. Now if we compare that to if we didn't have a pulley system, the force would be about 44 newtons, which is about 4 times as much. Now, let's see if we can lift 20 pounds, which by themselves I probably would not be able to lift them, but attached to the pulley system makes it a lot easier. So I'm able to lift them, and it works out pretty well. All thanks to pulleys. So let's go back to the program, see how much force it took to lift those right there. 20 pounds, mechanical advantage of 4. It's about 22 newtons, which is about how much force it would take to lift the 5-pound weight directly off the ground without a pulley. Now let's see if we didn't have a pulley. It'd be that was with the pulley. Let's see if we don't have the pulley. Let's compare it. Mechanical advantage of 1. It would take about 88 newtons of force to lift it, which is about 4 times as much. So, in conclusion, pulleys make lifting heavy objects a lot easier. They cut down the force needed to lift it by a fraction determined by how many pulleys you have, but it also increases the distance needed to pull the rope to lift that object by an inverse of the fraction of the force. So pulleys are great, and thank you.